A screen lights up with a single word, Italian. That's the result, the whole result, sitting there like it explains something. But it raises a question almost nobody stops to ask afterward. Italian since when? Italian compared to who? Because most people, when they picture the ancestors behind that word, picture one of two groups. The Romans, marching out from their capital in togas and legions, or the Etruscans, that older, stranger civilization that came before them, painting tombs and speaking a language nobody else on Earth understood. Both feel like solid answers. Both feel like the bedrock under that word on the screen. Neither one is the real answer, or at least not in the way people assume. Here's the first problem. The Etruscans, the group that looks the most foreign, the most mysterious, the most like outsiders who parachuted into Italy from somewhere else entirely, turn out to be genetically almost indistinguishable from the Romans living right next door to them. Same ancestry, same genetic architecture. Practically twins once you strip away the culture and the language and look only at the DNA. Here's the second problem. The Romans themselves were never a fixed genetic population to begin with. Ancient genomes recovered from in and around Rome show one of the most churned over, most reshuffled populations anywhere in the ancient Mediterranean world. Not a bedrock, not a stable core that stayed put for 1,000 years. A population in constant motion. So if it wasn't the Romans holding the genetic center, and it wasn't the Etruscans either, that leaves an open question standing in the middle of this whole story. If it wasn't the Romans and it wasn't the Etruscans, then who were the people whose genes are actually sitting in Italian DNA today? That's what the next 20 minutes are going to answer, using ancient genomes pulled directly out of the ground. Not folklore, not assumption, not a single simplified label on a testing company's website. 3,000 years of migration, replacement, and admixture, tracked site by site. Subscribe now if you want the receipts on this one, because there are 12 archaeological sites worth of them coming up. Long before Rome existed as anything more than an idea, the Italian peninsula had already gone through 2 complete population turnovers. By the time Rome was traditionally founded, around 753 BCE, the ground beneath it had already changed hands genetically, twice over. The evidence comes from one of the most extensive ancient DNA projects ever run on this region. Researchers led by Margaret Antonio sequenced 127 ancient genomes recovered from sites in and around Rome, spanning an almost unbelievable 12,000 years. The earliest hunter-gatherer populations captured in that dataset are not the ancestors of anyone reading a modern DNA test result. That lineage effectively dead ends. The first major disruption came with the arrival of farming. Neolithic populations moved in and, genetically speaking, all but erased the hunter-gatherer signature that came before them. This wasn't a blending at the margins. It was a near-total replacement across the region. The second disruption came later, during the Bronze Age, with the arrival of steppe-related ancestry. This is the same genetic signature tied to the broader spread of Indo-European languages across the European continent. It moved in, settled, and became part of the baseline. By the point Rome actually exists as a city-state, the genetic makeup of the region already closely resembles what we'd recognize as broadly Mediterranean. The so-called ancient baseline that people assume sits underneath everything else is not ancient at all, in the sense of being original. It is already the product of 2 prior replacements. There's one more detail worth holding onto here. That Bronze Age steppe signature, the one tied to Indo-European expansion, doesn't stay confined to the population that would go on to speak Latin. It surfaces somewhere else entirely, somewhere the linguistic evidence says it has no business being. That steppe signature didn't stay confined to Latin speakers. It shows up somewhere it has no right to be. Start with the language, because that's where the trouble actually begins. Etruscan is a fully documented, well-attested ancient language, inscriptions and all, and it has no known relatives, not one. Not a sister language, not a descendant, nothing living or dead that connects to it. In a landscape saturated with Indo-European tongues, Etruscan sits completely alone. Ancient writers noticed the strangeness immediately and disagreed about what it meant. Herodotus claimed the Etruscans had migrated in from Anatolia, in what is now Turkey. Dionysius of Halicarnassus took the opposite position, arguing they were indigenous to Italy all along, native rather than foreign. For centuries, nobody could settle it, and modern science didn't immediately help. Pre-2021 mitochondrial DNA studies produced conflicting signals depending on which population they compared. Some Tuscan mtDNA samples showed genuine Anatolian affinities, supporting Herodotus. Other studies found no continuity whatsoever between ancient Etruscan remains and the modern population living in the same region today, undercutting both theories at once. The debate dragged on for over 2 centuries without resolution, and the reason wasn't a lack of scholarly effort. It was a lack of raw material. There was almost no usable ancient DNA from Etruria itself to test either claim against directly. Part of that gap traces back to an earlier culture entirely. The Villanovans, the people who lived in the region before the Etruscans, cremated their dead. Cremation destroys exactly the kind of genetic material historians would need centuries later, wiping out the record of the very population that could have shown where the Etruscans came from. That changed in 2021. A team publishing in Science Advances finally assembled what the field had been missing: a genomic time transect built specifically to settle this question, drawing on 82 individuals recovered from 12 archaeological sites, spanning 800 BCE all the way to 1000 CE. The result didn't just settle the debate, it reframed the entire question. The finding stated plainly is this: the Etruscans shared the same genetic profile as the Latins, living right next door to them, in and around Rome. There is no evidence, none, of a recent migration from Anatolia. Herodotus's theory doesn't survive contact with the genome. Both populations, Etruscan and Latin alike, carried a large proportion of that same steppe-related ancestry that had arrived centuries earlier during the Bronze Age. The same wave, the same source, no separation between them at the genetic level at all. That's the mystery sitting at the heart of this entire episode's title. A population that is, genetically, indistinguishable from the ancestors of Rome itself, speaking a language that has no known relative anywhere on Earth. Two peoples who were, biologically, one people, and linguistically, total strangers to everyone around them. There's an added layer of irony here. Steppe-related populations are broadly credited with spreading Indo-European languages to what is now billions of speakers worldwide. So finding a non-Indo-European language isolate sitting directly on top of steppe ancestry makes the Etruscan case even stranger, not less. David Caramelli of the University of Florence and a senior co-author on the study put the disconnect this way: genetic turnover and linguistic turnover simply didn't move together here. The genes changed on one track. The language stayed on another, entirely separate one. His proposed explanation is admixture rather than invasion. Early Italic-speaking populations may have been gradually absorbed into an existing Etruscan-speaking community over a long, slow period of intermixing stretched across the second millennium BCE, rather than any single dramatic migration event. So the Etruscans weren't foreign invaders, and they weren't a separate people hiding in plain sight. They were Rome's genetic twin, speaking a language nobody else on Earth spoke. Picture the 8th century BCE Italian peninsula, and Rome disappears into the crowd. It's one of dozens of competing city-states scattered across the landscape, no different in genetic terms from its neighbors, nothing marking its founding population out as special or destined for anything. The data backs this up directly. Antonio's research shows that the genetic composition of the region at Rome's founding already resembles the broader Mediterranean population of the time. There's no unique isolate here, no hidden genetic advantage, no distinct bloodline waiting to be discovered. Just an ordinary population living in an ordinary settlement among many others just like it. And yet in less than 1,000 years, that modest, unremarkable genome would sit at the geographic and political center of an empire controlling somewhere in the range of 60 to 70 million people. An empire of that scale, and until relatively recently, almost nothing was actually known about the genetics of the people who ran it. It took Antonio's 2019 study to fill in a gap that had simply been sitting there, unexamined, for the better part of 2,000 years. That gap matters because of what fills it next. The transformation that Rome's small founding population was about to undergo wasn't driven by battlefield conquest in the way people usually imagine empire. Legions marching outward don't, by themselves, rewrite a capital's gene pool. What actually reshapes a population at that scale is logistics. The movement of soldiers, administrators, traders, and enslaved people, flowing inward toward the center of power over generations. So hold that image of Rome as one unremarkable city-state among dozens. It's about to become something else entirely, and the mechanism won't be armies crossing borders. It'll be people crossing them, in numbers large enough to change what Roman genetically means within a few centuries. Expansion on that scale doesn't just move armies. It moves genomes, and Rome's own DNA was about to change more than any territory it conquered. The imperial period is where Rome's population stops looking like itself. Ancient genomes from this era show the city receiving a substantial wave of net immigration from the Near East, and the scale of it is not subtle. Researchers found that roughly half, close to 50% of the population's ancestry during this period traces back to Eastern Mediterranean sources. The mechanism is not mysterious. It's built directly into how the empire functioned. Trade networks, military postings that rotated soldiers across provinces, and the machinery of slavery all physically relocated enormous numbers of people toward the capital, generation after generation, until the demographic weight of the empire's eastern provinces was showing up directly in the DNA of the people living in Rome itself. Johannes Krauss framed this shift as a reflection of a period marked by unusually high social and geographic mobility, both upward and downward, moving across the empire in ways that left a genetic signature behind wherever people ended up settling, which produces a genuinely strange outcome. The population living in the literal capital of the Roman Empire, at the height of its power, was on average genetically closer to the Eastern Mediterranean than to the founders of the city they were living in. The center of Roman political identity was, biologically, no longer especially Roman at all in the ancestral sense. And this wasn't confined to the urban core. A second, smaller study focused on a rural site called Quarto Cappello del Prete, dated to the 1st through 3rd centuries CE, reinforces the exact same picture. Out of 48 individuals examined there, the majority carried dominant Eastern Mediterranean ancestry. Only 2 individuals in the entire sample showed haplotype sharing with North African populations, a small but real signal that this Eastern-leaning shift wasn't confined to the capital's elite either. Move outside the capital, and the pattern holds. Rome's genetic reach ran through her farmland too. The Eastern surge wasn't the end of the story. Antonio's research documents a second shift within the imperial period itself, a rise in genetic contributions from Europe, arriving on the heels of the earlier Eastern Mediterranean wave. These shifts weren't scattered or random. They tracked, almost point for point, the geopolitical alignments of the empire at any given moment, moving in step with whichever regions Rome was actively administering, trading with, or drawing soldiers and labor from at the time. One detail from the study stands out on its own. Researchers noted marked inter-individual diversity within Rome during this period. In practical terms, no 2 Roman households necessarily shared anything close to the same genetic background. Neighbors on the same street could carry ancestries pulled from opposite ends of the empire. Put plainly, the picture that emerges from this data is not one dominant Roman genetic type sitting at the core of the empire the whole time. It's a shifting composite, reassembled generation after generation depending on whatever was happening across the empire's borders at that moment. That single fact undercuts a very popular assumption: the idea of a single ancient Roman bloodline that modern people could somehow trace back to or claim ownership over today. The data simply doesn't support a bloodline in that sense. It supports a moving target, reshaped repeatedly by the empire's own reach. And empires built on that kind of constant demographic churn don't last forever. Within a few centuries, the very structure that had been pulling an Eastern Mediterranean ancestry, then European ancestry, then some new combination of both, collapsed entirely. A completely different wave of people was already moving in to take its place. The fall of the Western Roman Empire arrives in the 5th century CE, and central Italy doesn't get a quiet transition. The genetic change starts almost immediately. Sardinia occupies a strange place in the genetic literature. Over and over, researchers describe it using a specific term: a true population isolate. It's a designation almost no other part of mainland Italy earns, and it comes directly out of the data, not out of any romantic notion about island life. A Y chromosome study covering 930 Sardinian men found something striking. One particular haplogroup, IM26, showed up at a frequency of 0.37, nearly universal across the island's male lineages and essentially absent everywhere else in the Mediterranean. That kind of concentration doesn't happen by accident. Researchers interpret this as a founder effect. A relatively small original population settled the island, and its genetic signature simply never got diluted the way mainland populations did through centuries of migration, conquest, and admixture. Whatever walked in genetically at the start largely stayed. There's a historical anchor for this. The Nuragic civilization built thousands of fortified stone towers across Sardinia during the Bronze Age. An enormous construction effort tied to a population that was, by all evidence, large enough to sustain itself but isolated enough to avoid the constant genetic churn happening elsewhere on the peninsula. Later research pushed even further into the island's structure. Whole genome analysis covering more than 3,500 Sardinians revealed additional substructure within the island itself. The mountainous Ogliastra region in particular shows even tighter isolation than the rest of Sardinia, almost certainly the result of restricted gene flow across genuinely difficult terrain. The isolation isn't just an academic curiosity. It carries real medical weight. Sardinia shows an elevated incidence of autoimmune conditions, including type 1 diabetes and multiple sclerosis. And researchers tie this directly to the same genetic bottleneck responsible for the island's unusual Y chromosome profile. Isolation locked in more than ancestry. It locked in risk. Sardinia proves what happens when a Mediterranean population barely mixes. Sicily proves the opposite extreme. Sicily sits at the literal geographic center of the Mediterranean, and its genetic record reads like a ledger of every major power that ever passed through it. Nothing here got the chance to stay isolated the way Sardinia did. The historical waves are well documented, and each one left a distinguishable genetic signature behind. Greek colonization, Phoenician and Carthaginian settlement, Roman rule, Arab-Berber conquest, Norman conquest. 6 or 7 centuries of layered history compressed into one relatively small island. The Y DNA numbers make the largest layer obvious immediately. An estimated 37% of Sicilian male lineages trace back to Greek origins, carried in haplogroups E1b1b, E3b1, and J2. That makes the Greek contribution the single largest identifiable ancestral layer anywhere on the island, larger than any other named source. Arab and North African linked ancestry, marked by haplogroup J1, sits at roughly 6% overall, but that number isn't evenly spread. The town of Ragusa shows the highest concentration on the island, at close to 10%, well above the Sicilian average. Norman-linked ancestry tells its own separate, geographically specific story. Haplogroup I1, tied to Norman settlers, concentrates specifically in northwestern Sicily, around Caccamo and Palermo. In some local samples from that region, it approaches nearly a third of all lineages recorded, a striking figure for a conquest that arrived comparatively late. There's one more regional detail worth sitting with. Mazara del Vallo, a town originally founded by Phoenician settlers, shows an elevated frequency of haplogroup L, a lineage with deep roots stretching back toward the Near East. The town's founders left a genetic signature that outlasted the empire that founded it. No single conquest ever managed to overwrite the one before it. A 2026 ancient DNA study proved that directly in the bones themselves. That study carries a direct, specific name, Genetic Histories of Individuals from Multi-FOA, open a testing kit results page, and the complexity of everything covered so far collapses into a single word: Southern Italian, Sardinian, or just Italian. 3,000 years of distinct migration events, folded into one tidy category. Sicilian test takers feel this flattening more than almost anyone else. Unexpected percentages show up in their results labeled Western Asian, Greek, or North African, and those numbers aren't glitches. They're a direct echo of the Greek, Arab, and Norman layers already documented in the Y DNA record, resurfacing decades later on a screen with no historical context attached. The surprise people feel makes sense once you consider what these categories were actually built for. Commercial ancestry labels exist for marketing clarity, something a customer can read in 5 seconds and understand. They were never designed to hold the level of regional nuance the genetic literature actually contains. The regional data makes that gap obvious. Ragusa carries its Arab-linked signal. Caccamo carries its Norman-linked signal. Mazara del Vallo carries its Phoenician-linked signal. These are towns sitting less than 50 kilometers apart, and yet their underlying ancestral proportions differ in ways a single regional label could never capture. The broader lesson sits right there in the averaging itself. A national label like Italian is doing an enormous amount of work, smoothing over what is, at the DNA level, one of the most layered population histories anywhere in the Mediterranean world. And that averaging is exactly what makes a title like this one, not Roman, not Etruscan, technically true for almost everyone on the peninsula. Go back to where this started. The Etruscans were framed as the mysterious ones, the outsiders, the people with no linguistic relatives and, presumably, no genetic relatives either. The evidence says otherwise entirely. They were genetically Rome's own neighbors, which means Etruscan DNA, as its own distinct category, barely exists at all. Rome fares no better as a fixed anchor. Imperial Rome's own residents were, for real stretches of the historical record, majority Eastern Mediterranean in ancestry. The capital of the empire wasn't holding some pure ancestral line in reserve. It was one of the most demographically fluid cities in the ancient world. Put plainly, both of the assumed anchors for Italian identity, Roman and Etruscan, turn out to be moving targets rather than fixed points anyone could actually plant a flag on. What actually sits inside modern Italian DNA is a composite: Neolithic farmers, steppe pastoralists, Levantine and Anatolian arrivals, Germanic settlers, Greek colonists, North African and Norman medieval populations. The exact mix shifts depending on precisely where on the peninsula someone's ancestors happen to be from. There's a quieter irony buried in all of this. The two answers this title rules out, Roman and Etruscan, were never actually competing with each other genetically in the first place. They were largely the same population, dressed in two different cultural and linguistic identities, mistaken by history for two separate peoples. So if it isn't Roman and it isn't Etruscan, the honest answer is that it's all of it, unevenly distributed, and still being mapped. That mapping isn't finished. Even with 127 genomes recovered from Rome and 82 from Etruria, the researchers behind this work are the first to say more ancient DNA is still needed across Italy before some of these conclusions can be treated as fully settled. The Etruscan study team acknowledged this gap directly. Ancestry shifts detected in Tuscany and northern Lazio parallel what was found in Rome, but sample coverage across the wider peninsula remains thin in places, leaving real gaps in the record. Entire regions are still underrepresented. Much of the deep south, more of inland Sicily, more sites across the Alpine north. None of these areas have received anywhere near the dense ancient genomic sampling that Rome and Etruria have now benefited from. The implication is direct. Everything covered across this episode, however well documented, is still a partial reconstruction, not a finished map of the peninsula's genetic history. There's a real chance the next wave of ancient DNA sequencing could still overturn or refine details sitting inside this very timeline. The Etruscan question itself was only considered settled as recently as 2021, and that came after more than a century of open dispute among historians and geneticists alike. Which means the story of who's actually in Italian DNA is still being written, one archaeological site at a time. So the next time a test result says simply Italian, what 3,000 years of migration is that one word actually hiding?